All right, hi guys. So welcome once again to another section of learning. So we want to continue question 2 on the DFA journey we started. So if this is your first time, consider liking this video because you will have a lot of things to learn, and also stick to this channel by subscribing, become a family of this channel, so you will learn always on this channel. Okay, so I urge you to subscribe. Thank you very much if you've done that, and if you've not done that, you can do that now. Don't procrastinate. So let's look at this next question that says, the question says, the question says, uh, convert, sorry, not convert, construct a DFA that accepts set of all strings over 0, 1 of length 2. Now, okay, so let us see how do we solve this question. Still the same way what we did, but the algorithm we are looking out for here different. It's different from the first one that says we should check out for strings that start with what? 0. That's for question 1. But this one now says we should check out for string over 0 and 1 of length 2. So we are working with that of length. You see the reason why we need to understand those mathematical notation. So if we are saying length 2 now, there's something we need to do to the alphabets. So solution now. Firstly, we need to get our alphabet. What's our alphabet? Alphabet is 0, 1. So from here now, we can see how to extract our strings. So the strings, they said that accept set of all strings over 0, 1 of length 2. That means each of the strings is going to be a set of 2. So if we have that, that is what? 0, 0, right? Sorry. 0, 0, 0, 1, 1, 0, 1, 1. Now, we've achieved this. So the next we need to do is to see how we want to construct the DFA that accepts set of all strings of such. So firstly, we have the, let's use our A as our start initial. So if we have the first one, we have 0, 1. See, 0 or 1 enters. They said length 2, and this is length 2. No, we can't start with 0, 0. Reason because if we say length 2, it simply means that it is either what enters here is 0 or 1. They didn't say what enters here is 0 over 0, 1. Okay. So next one is what? We'll move to what? The B state. B state now, we have another one. Don't forget, length 2. So look up. If this is 1, this is what? This is 2. We've satisfied what they want. Length 2. This is 1, this is 2. If you are seeing this one as, why could you say this is 1, this is 2? But I'm having 0 and 1 here. Remember that the 0 and 1 are not entering at the same time. It is 1 that we enter. So here now we will have 1, whether 0 or 1. 1 enter, 1 input. Here we have another one, whether 0 or 1, 1 entered. So it makes up what? 1, 2. two strings, two lengths of strings. It's okay that way. So the next thing we need to do here is to see over. Yes, what we mean by that, over, that means we need to expand this 0 and 1. Remember that this thing here, I can change it. See, I can change this one to be over alphabet. It's the same thing. So this one now will lead us to what? C. And this C becomes our final because we've been able to get 1 and 2, the two lengths of strings we are asked to look out for. So this is our final here now. So this one being our final, what do we do next? Are we going to see, we've already achieved what they asked us to. We've met up to their demand. Now, what happens if peradventure there is extra input that is beyond what they asked for? Like the first one now, they said 0. We check out for 0. Later, we now check out for what? 1. That is not part of what they asked us to check out for. So that's what we want to do now. In checking out for that, that's the reason we need to have what? Since we have length, string of length 2, we extend it to what? Length 3. Peradventure, just to show them that, okay, this is how length 2 looks like, string of length 2. But I am having here also string of length 3. In case there are questions given to you and you are asked to check, even though they give you questions, they ask you to check, it will still not it will still not show up anything, because even when we got this one, the first question one we did that we extended it to what? We extended here to C. The answers, when we begin to check, anything that moved down to this place wasn't accepted. But nevertheless, we still need to what? Show it. It will still be part of the DFA design. So the fact that it's not accepted, so why you need to show it is the fact that, so that when there is a question that is not accepted, we can't know yet until we just have to put it. So when there are questions, as questions are coming, they say, okay, check if this is accepted by this DFA or not. If it's accepted or if it's rejected, we just have to put it there. So if we put it there, when that time comes, we will know. So we already know where our starting point is, starting state is, and where our finish state. So this is the beginning and the end of what they asked us to do. So we can just decide to extend this one now, 0 or 1. Extending this one 0 or 1, it gives us what? D. But this D is not what? Finished state. It's not a finished state as it is now. It's not a finished state. Reason because it's not a finished state is because we have achieved what they asked us to achieve at this state. This one now is just to show them that I have achieved what you asked me to achieve. But here, in this case now, if peradventure I am having something of strings of length what? Length 3, SS. This is what I'm going to have here. So in case there is any other thing that happen, and this one now we have step loop. Good. This one now having step loop. Finish state. Yes, yes. Good. That's a good question. Why do we have another branch here? Now, if we solve this and this, you will find out that even this one we have here, doesn't still matter. Reason because when we have questions given, if question is given to us, we find out that this one does not matter, because anything that exceed this place will still not be accepted. It will still not be accepted at all. It can't be accepted. So we just put a self loop here. So let us see. Let's check out now. The first one now, let's check out for 0, 0. Example under this. Let's say example, we're checking out for 0, 0. Now, 0, 0, sorry. The first one here, we have what? If A enters it, 0. So we have 0 here, which leads us to what? To B. The second one is what? 0, 0 here. That leads us to what? To C, right? What is C? C is finished state. So that tells you that 0, 0 is accepted in this case. Good. Another one is that if we have, let's say we have 10. Okay, we still do that one. We have 10 now. Let's see if 10 is accepted or not. 1, 0. No, we don't say 10. I understand what it means. So let's say we have 1, 0 here in this case. And the first one that enters, we have 1, which is A, right? 1 enters. That one leads us to what? To state B. Then from state B, we have another one that enter, which is what? 0. Another input 0. It leads us to what? State what? C. Is state C the is it the final or not? Let's check.
What enters state A?
1. State A. State B, 0. And leads us to state C.
1 enters state A. 1 enters state B.
1 enters state A. 1 enters state A. From this, will lead us to state B. We still have 0 here now. So 0 enter state B. If 0 enters state B, it leads us to where? State C. That's what we have here. It's accepted. So let us look out for 0, 0, 0, 1. So let's see 0, 0, 1. What happens? 0 enter. The next one is what? It takes us what? To B. Right? 0 enter again from that B. It takes us to what? To C. What enters again? 1 enter from what? From C. Taking us to where? To D. It takes us to D. So we now ask ourselves, is D the final state in this DFA? No. D is not the final state. Therefore, this 001 is not accepted. Because we've exceeded the what? The last state there is what determines whether it's accepted or not. And the last state there is D. And D is not the last state in the DFA. The real DFA here, D is not the last state, but D is the last state according to the question given to us.
So, can you say, what if we draw this one? What if we say, from that your diagram there, A, draw your A.
Okay. I'm into.
A.
What if we drew it?
But they need that to defend the DFA.
Okay. We have it out. A.
Self loop 0, 1.
Self loop 0, 1.
Move to B.
Move to B.
Self loop 0, 1.
Self loop 0, 1.
Move to C.
Move to C.
Final state.
Now, if you are doing self loop, how come are you starting with self loop when we did not have input in the first place? Because the question is, how come did you get into this compound when the gate was not opened for you? That means you passed through an illegal.
There won't be a forward movement to B.
You get it now?
You know what I'm saying? So,
Why?
because when we start, we input the value A,
Mm.
and we're checking for 1, 0.
Mm.
When 1 goes in,
Mm-hmm.
that value only holds 1.
Yes.
You see, DFA is finite.
Yes.
It's only 1.
Mm-hmm.
So where does the next 0? What's holding second 0 value?
Now, according to the questions, the question says that set of DFA that accepts set of all strings over this and this 0 and 1 of length 2. It simply means that we are going to show the fact that I'm having 0 and 1 here does not mean that I am having the two entering at the same time. What is at work at every time I'm checking input from one state to another is one. Is one, the possibility of one input. So that one input, they didn't tell us that one input whether it is what it may be, whether it must be one or it must be 0. You get it now? So what they just told us is either 0 or 1. So since they didn't tell us if it is 0 or if it is 1, that's why we have to put 0 and 1. Just put it there. But you know quite well that what the input that you have here is just one input. One input you have here. This one, that's because of that one input now. See, if I remove this now, you are seeing 1, right? If I remove this now, you are seeing 1. So putting this 1 here again, it is just you telling you that, okay, since the question did not specify, telling you that only 1 or only 0 is accepted. If the question specifies that, then you would have just say, okay, no, I'm not putting 0 or 1. It is either 1. Since they told me it is 1 that is entering, you follow it strictly. Since the question did not indicate that, you just have to put it there for them. So you can't have self loop where there is no input in the first place. No. All right.
Do set of all string
Okay.
of length two
Of
without that over do it DFA for set of all string of length two.
there is no way you want to do strings. See, Frank, that there is no way you want to do a string without it being over 0 and 1. Because 0 and 1 is the alphabet. That is where strings are generated from. From the definition.
It's only the length that can change.
It's only the length that can change.
Okay, of length one. Okay, of length one.
If we do length 1 now, that means they will tell us that it is either, they will tell us that this one, that length 1 own is what we did as example 1. They will tell you, okay, start with that accept, start with 0 or that start with what? With 1. So that one now is length 1.
You really have those three alphabets.
Exactly. So that's for that. Now, let's see another one. Let's say we are given 1 and we are asked to check if this one enters. Does this one enter? If we have here, 1 enters here, it takes us to what? To B. That's all.
But not the final.
It's not the final, so 1 is not accepted. So that's for that. So
What of the transition table?
the
Transition table
transition table.
for this one.
Our transition table has nothing to do with this. That transition table was actually showing us how that a particular state move from its current state to another state. That's what that thing is showing us. And we are already making use of transition here because we are moving from one state to another. You get it now? And what we are, the aspect of transition here is each question given to you, the instructions. That's what will determine how your transition will go. The first one, our transition was based on strings that start with what? 0. This second one, our transition is based on strings of what? Of over 0 and 1 of length 2. And we followed it. So this one now, at this point now, we transit from here, from A to B, from B to C. Better, final state. Extending it to this place. This extension here is just to show us that, we've achieved this final state here. It has indicates, telling us that this one here, we have achieved what we are asked to do. So this is an SS. In case there's SS. And this one here, anything that ventures enters here, forget it. It counts. It won't be accepted. Same thing we have that C, the first question. Whatever that enters that C wasn't accepted. It will be rejected. But we just have to show it in the diagram. So that's for that.
The set of those of the alphabet. Set of that set all have the same DFA.
Which one?
All the DFA will look alike for those two strings.
For this, yes. For the two strings, all the DFA will look alike.